Well, good morning. I'm going to be talking about a different project, obviously, but I think much of what I say kind of parallels and reflects what Becky just laid out, so I think that's good. First of all, my name is Jim Costello. I'm the lead developer at the Center for Technology and Government at the University of Albany. I'll be talking about a project that we worked on with the New York State Department of Health in regard to their open data and data visualizations. I have lots of notes here. It might look unprofessional, but they'll keep me on target because I have a tendency sometimes to get distracted, so I don't want to do that. So basically, what I want to do at the start, just start with a few slides. I want to kind of set the landscape of this particular project because, as you might have picked up from Becky's talk, and you know just from your own experience, open data, data visualization, it's a vast universe. There's all kinds of data involved. There's all kinds of ways to portray that data. It's not one thing fits all. So just looking at the particular project we worked on with the New York State Department of Health, just kind of to, so we know what I'm talking about when I'm talking about open data and data visualization today. And actually before that, before we even start any, and we've done a few different projects of this nature, we always start with a few questions regardless of what the specific project is. These are questions related to data visualizations, but they almost relate to any project in general, but more specifically, the types of things we want to ask ourselves and ask in conjunction with our clients when we step into a project of this kind. First of all, forget about the data, at the start. Look at who you're communicating, what you're trying to communicate, the people you're trying to communicate it to, understand the audience. So we focus as much, especially at the beginning, on the audience as on the data. What do we want the data to tell them? What's the basic message you want all your users to get? And I know you outlined a couple different types of users you had in your project, and most projects have that. They have more than one type of user. So we try to specify and understand that audience. And then once we know that, then look back at the data and what you're trying to do with it, and ask yourself, does the audience have the knowledge to interpret your visualizations? Are you giving them something that they're going to be able to understand, or can they misunderstand it? And if they can, what do we need to do up front to guard against that, which would really be a failure on our part of who's ever trying to do it. So those kind of things hover in the background and throughout the project of any of these projects that we do, and this one in particular. So that kind of gets us going. And in this particular project, we had, there were a lot of different parameters, but two of the main focuses of the project. The first one was, could New York State Department of Health use its open data to improve their internal processes and produce better visualizations? So they were looking, it was as much a workflow improvement, a business process improvement project, as it was a data project. Data was going to be used as the or the means to get to that end of improving their workflow. So throughout the project, we were, and again, the example of going from 29 FOIL requests to 1 FOIL request in Becky's presentation kind of demonstrates that kind of impetus to these types of things. You want to make things better, not just produce pretty pictures, in other words. So with that as the underlying motive, then could we do it in a way, and this was very important to DOH with this particular project. They wanted a way that would be durable, meaning once we did it, could they repeat it next year and next year and next, without having to go through the whole development process again? Was it something that would continue for year after year as the data changed, as the world changed? Could they just continue without complete redevelopment? Was it flexible, meaning that once you produce something, the minute people see it, they say, ooh, that's good, I want this, I want this, I want this, I want this. Would it be able to offer more options? Could you adapt it to the situation so that they didn't just get something that they were stuck with in that regard? Was it portable? Once they have loads of data sets, as most of you, I mean, how many people here have open data, open data sets that you work with within your agency organization? How many have more than one of those open data sets? So again, I don't know exactly how many DOH has, but it's dozens of data sets on the data platform. They wanted a way that once they did it for one data set, well, could we take this and apply this to the dozens of other data sets, again, without completely redeveloping things? Was it transferable? Meaning, once you guys develop it or help us develop it, we want to be able to put it on our website without, like, you know, putting in a whole new web server, a whole new application server, all sorts of crazy implementation things. We just want to, you know, it's a web, the project we were working on was a web-based visualization. They wanted to just put it up on the web and be done with it. So that was important too. And that got into the question that John was alluding to earlier about all the different types of tools and software options you have within this universe. That kind of drove our decisions in that regard. And then finally, was it understandable? Was it written, was the code written in a way that once we handed it over to the DOH team, would we hand them over something that said, thanks guys, what did you do here? You know, or would it actually make sense to them? They could say, okay, we have to go in and fix this or modify this for next year. Could we easily go in and modify the code? So we made sure that the code was developed in a way that adhered to the industry standards for that language, or that scripting language, and that it was, you know, fully commented and all those kinds of things so that they could follow it through. So the project itself, it went over a few phases. We started in the summer of 2015. At that point, it was just more like a proof of concept, a feasibility thing. They wanted to know if this was actually a sensible approach, could it be done? So we spent a couple months just working with their open data and trying different tools, different ways of visualizing the data, different ways of improving the workflow to come up with something that, see if it was in fact feasible, which we did, and they thought so as well. So from there, we went ahead in the February to October of 2016, where we developed and delivered code for the first data set, what they call the EQUAR, which is Quality Assurance Reporting Requirements. Basically, it's reporting they have to do that evaluates the different healthcare plans across New York State, CDP, HP, Empire, those types of things, on different measures, such as health measures, like how are they doing with treating bronchitis, with diabetes, with those kinds of things. It's a reporting mechanism they've done for decades, and they have the open data on that, and they have reporting on their site, so they wanted to bring it over. So that's what we focused on, the data set for the first time. That worked out fine. It's live on their website as of now, as of October of last year. And then, again, once they did it for that data set, they moved into a third phase. They said, well, you know, we do have all these other data sets. So can we take that code and apply it to these other data sets? And that's what the final phase of the project did encompass. So those are the timeline of the project. This is just to give you an idea, again, of what we're talking about when we're talking about data visualization for this project. And again, it's very similar to what NYSERDA just showed you. You know, there were tables, and there were graphs, you know, simple charts, and then some kind of interface that made it, flexible for the user to choose different options and so on. This was actually developed as part of the prototype. This wasn't one of the final visualizations, but this was one of the proof of concept things that said, yeah, I think we can, I think this is a reasonable thing to be able to do. Our data visualization process, and this is kind of cool. I kind of noticed this last night, but I left it because I thought in a perverse kind of way it was kind of interesting in terms of visualization. This actually says investigation of user needs and expectations. But when I sent my slides over, my typeface was obviously a different typeface, so when they brought it into the form, it substituted a face that got too big, so you can't actually see it. Invest them. But when we get to the end of my presentation, I mean, the idea of testing and understanding how things look in the world of visualization is very important. So, you know, I don't mind making fun of myself, obviously, but I kind of blew it here. But that's okay, because I was aware of it. But anyway, that's one of my digressions. I should have been checking my notes. What I want to focus on is the process. And this is, again, I think it's not unlike the process you outlined. we start down here with the user needs and what we call data forensics, which is really looking at the data. We spend a lot of time looking at data, analyzing data, loads of time looking at that. Understanding what the data is, looking at things that need to be fixed, things that aren't there that should be there, things that are there that you wonder why the heck they are there, those kinds of things. That leads into the code, whatever code we decide to develop, and do the application and testing, seeing if it's meeting what the users want, and also leveraging the data to its greatest extent. And that, at the end, you come up with the visualization, which is the final product. However, as you can see, with all the rotating circles and lines coming back, these things, they're all happening at the same time as well. So when we're down here at the beginning talking to users and doing data forensics, we've already started creating visualizations and using code, and they're all constantly feeding back to one another. So it's a very, in one sense, it's a iterative process going up, but at the same time, everything's happening at once. We don't wait till all this stuff is done and then start creating the visualization. So that's why there's all those crazy circles and things. Choosing the right platform. For this project in particular, we looked at the beginning based on those parameters they had of workflow and then the durability, flexibility, et cetera. We looked at a lot of software and different open source code as well. According to this criteria, could it handle small to large data sets? You know, the data sets we were dealing with, they weren't like, you know, super huge, but they'd be up to maybe 150, maybe the biggest was 500,000 rows of data. I'm not sure it even got that high. Some were as small as 150, 200 rows of data with 5 columns. So they'd be from very small to significantly large. I wouldn't call them big data, but almost big data. Integration, did it have flexibility that we could apply to all types of data sets and work through that iterative development process? Was the software lend itself to being, you know, rapid development type of thing? Frequency, could it support data sets that are updated and changed on a regular basis? What we ended up doing, same thing that NYSERDA does, we're just using the API from the open data set, taking the data set, the data in live. We're not like bringing it into another platform, another database, manipulating it, and creating an interim data set to produce a visualization. So that's how we dealt with that. And a degree of customization. Could it be modified to meet users' needs? Because again, not only yourself, when you see something at first and you like it, and 2 minutes later you go, oh, you know, I should have done this, you know, I should have done this. Could you make those kinds of modifications on the fly? And in response to users, they say, that's nice, but could you show me this? So on the 3 steps, the forensics, you got to determine if the data is accurate, consistent, complete, and appropriately structured. If it's not, meaning if it's not visual, and what we call visualization, right? Meaning based on what you decided you want to show your users through these visualizations, does your data support that? Data doesn't just sit out there as a, you know, raw material, magic resource that somehow you can make it do whatever you want. You want to go back and make your data do what you want your data to do. Recommend ways. So we have a lot of conversations back and forth with the data governance people, the data experts within the agency on how they understand the data, how we understand the data, and how to make the fixes that will improve the data. And then we create the initial visualizations to show how well the code and the data align. And again, that would iterate throughout the duration of the project. At the same time, we're analyzing the user needs. We have people who actually go out and talk to the users. Users within the agencies, the users who own the data, outside users, say, and just talk to them. You know, they're better than I am. I mean, they're actually professional researchers who know how to talk to people and get information and process that information. Just to understand how users are using the data. And then again, based on that information, determine changes that need to be made to the data sets and or the code to meet those needs. And the way our teams work, just physically, our user researchers, our technical coders, we all kind of sit in the same cubicle. It's a pretty big cubicle. I don't want to make it sound too weird, but they're talking all the time, you know. So they talk to the users come back to talk to the people who are coding. They say, oh, yeah, I think can you do this? And they say, yeah, I think I can do that. Or if we can't do this, maybe, you know. So those kind of exchanges become real important in the process of the project. Then piloting and implementation. We would demo, again, and this would go, I mean, we had some very planned, structured presentations during the course of the project, but also just ad hoc presentations. We had it up on a demonstration website where at any time people within DOH and us could go in and look at where things were and say, okay, that looks good, or what are you guys doing here? Demo the visualizations to gather feedback, refine the code. At the end, our partners, in this case DOH, received a standardized, fully documented open source code and any other accompanying information such as data dictionaries. The way the implementation actually worked in practice was I zipped up the code. I sent an email to the developer at DOH, who, you know, I've been in contact with through the whole project, and a couple lines of instructions, and here, put this JavaScript library here put this here in your HTML, and that was it. That was the implementation process. It wasn't burdensome at all. So the workflow. This is a workflow with this eQuire that DOH was looking to improve. You know, it's a pretty good workflow. I'm not diminishing the workflow itself. It's a good job. They get this data from all the different healthcare plans in different places around New York State, would come into their research scientists who would bring it in. They'd use their tools, their SAS, SPSS, whatever it was they did for data analysis, and they had a bunch of macros they created. And from their analysis, then they produced their own internal data sets and data analysis. They produced the files that went to the Open Data New York platform, and in the middle, they created a bunch of HTML tables, individual HTML tables. It says 60 plus here, it's actually 75, I think, each year, that would then go out on the public website. And what they were looking to do in terms of workflow was get rid of this. Because they felt, and you know, we felt, and justifiably so, was if they had it here, they should be able to get it here. And so that was in terms of workflow improvement. What that meant for them is that, you know, all this work here, where you had 60 additional tables being created and manual replacement by the public web team and all the checking back and forth and fit into I don't want to say what we do say, poor user interfaces. It just wasn't as good of a user interface as it could have been or they would have liked. So what they went to was this, where they eliminated those two crossed out steps and actually got it to here, where now they go right from the open data set, boom, to the website. There's no intervening work at all. Once it's on the open data set, it's on the website. Boom, they're done. What that did for them in terms of the workflow, a couple months of full-time equivalent for research scientists. They don't have to create all those extra tables that they used to create. A couple weeks effort for the public web team to process those tables, check them back and forth, get them up on their website. They were able to improve their interface now because they had the platform provided it. It's single source driven, so they don't have to worry that this is reflecting the same data as this anymore, because there's no intervening. This is this. If it changes here, it changes there. If it's there, it has to be there. And it just expanded their opportunities for more visualizations. So our key lessons from that, and then this is the last line, then we're going to go into some of the examples. To me, this is the first one is the most important one, is to spend time up front getting to know your data. And we know a lot of times the tendency is to think, well, we spend time on the code to make the data work. And to me, that's a more wasted effort. Not that you're not supposed to spend time on the code, But if you can improve your data to the degree that it lends itself to these things, you can cut back on a lot of the unnecessary coding work, which is much tougher to maintain over time. Data has, when I say know your data, I mean really know it, like it's a person. I mean, because data has characteristics, you know. It has a character, it has a personality. You know, data's weird, right? We all know weird data. It can be resistant, it can be troublesome, it can be helpful, it can be pleasing. It's not often pleasing, but it can be pleasing. You know, I mean, it has those things, and you want to look at your data and understand what you want it to do and what it's doing. Know who the stakeholders are, know who the users are. Recognize that understanding the data can be more difficult than coding the solution, but it's worth it. You know, it's worth. Nobody minds telling the program that's what you're supposed to do. You're supposed to spend your time figuring out how to do stuff. But you can also spend your time figuring out how to get the data to work. Automate the processes where possible, and apply different technology options for different needs. Again, there's loads of tools out there. There's loads of ways to approach this. You got to understand what works best for your situation, your environment. Those are the lessons we took. I don't know if there's any that other people would have to add from your own experience. If you think that covers it, no? I mean, that's, you okay with us? So let me go into the, and you're welcome to interrupt me at any time. I shouldn't say interrupt. You're welcome to ask questions. So this is the, this is our one of our demo platforms of the project. This was at the end of the third phase of the project, when we had taken the original work from eQuar and applied it to the 4 different program areas, 42 tables, 17 charts, 6 maps, over 500 different views of the data. Just to, I'm not going to go through all those. Obviously, we don't have time, and I don't think we want to see them all anyway. But that's just to demonstrate how, in terms of the transferability and the portability of the code turned out to be. And again, that idea of durability, flexibility, portability, transferability, and understandability were very important to me. But what I want to look at to start with is the eQuar. This was the eQuar data, and what we ended up doing with eQuar. Let me show you what it used to be. Because again, these were tables, and again, tables are important for a lot of reasons that Becky kind of outlined. Let me go to eQuar. I have the old site. Because the old site isn't there anymore. It's like, for God's sake, I love it. The old site isn't there anymore, but just to give you an idea of what it used to be like, you would come to a page within DOH and they'd have this, where you could click on different years, and then on those years you could come in and they'd give you a list of all the different areas, commercial, HMO, adult health, and you could click on one, and then you get to their table. And this was the data. This was a 60 plus 75 tables they would show. So you can see these are the healthcare plans, CDKHP, advising smokers to quit, smoking cessation. So it had information, statewide average, national average, those kinds of things. They had, those were the tables they used to create by hand. What they moved to, and again, if you want, so now we're looking at managing acute illness for adults, commercial HMO. If you wanted to see a different measure, well, you'd have to click back, back through pages. There was no internal navigation, and actually on the original site you had to go back through several more pages, and maybe you could pick, another one for a commercial PPO, and then go forward and see it for PPO, and then go back and forth, back and forth. What they moved towards, the new project, something more like this, where now it's still the same table. This is still managing acute commercial HMO, you got your plans, you got advising smokers to quit, you got your, you know, your measures, your statewide, but all the navigation is within the page. So you could pick any year. Now, if I wanted to see it for commercial PPO, I would just come up here, click that, and there it is for PPO. If I wanted to see it for, say, children, I could go through all 75, and the other difference here, all this data now is coming directly from the Open Data, the New York State Open Data Set for healthcare. So all this data is what's currently on their Open Data Set out there. There's no, nothing intervening between it. So they got their table, which they wanted, which was important to them, but they get a few more features. Now, because of this platform, they can sort. So if they just want to look at lead testing, high to low, they can click the column, and now you're seeing it sorted. These are the lowest, these are the highest. Or if you want to, you know, do it for any of them, it can go back. If you wanted to see, say, you can look at a table like this, and you can kind of see, well, maybe you can see who's doing what and what's going on where. You see a lot of arrows and numbers, and if you spend time, you could interpret it. But you could click here, and you can see a bar chart, which shows you a lot quicker that, you know, certain ones are consistently below the statewide and average line, and some of them are consistently above the state line. So visually, you get the same data coming from the open data set, same as the table, but now you can see things a lot quicker and a lot clearer in the same way in a scatter plot. So now you can really begin to see that these, for one reason or another, below those averages. So that's one of the advantages they got from the original product. And this is the actual, so this is their actual site. What I was showing with my demo site, this is their actual site. So this is what's on their website right now. Again, it has all the same features. So this is what they went to. Not only improve their workflow, but also integrated their open data set with their web platform and gave them a few additional features to boot. At the same time, they wanted to, the first step was to, okay, that worked really nice. Now can we apply it to another data set? They went to, it was a similar data set, but it was different. It was still within this EQUAR area, but now it's about planned performances in different regions, commercial HMO. So again, you can see there's a lot of similarities in terms of the display, but even little differences, like now they're showing stars instead of numbers. Was your code flexible enough to manage to take numbers and, you know, substitute stars and those kinds of things? So this was our first case of taking the existing code and similar data set and applying it somewhere else and see if it works. So both of these things are currently live, implemented on their website today.
Jim.
Yeah.
What are you using to power your visualizations? Like what tool? Or
we're using D3, the JavaScript library.
Okay.
How many are people familiar with that tool? How many people have heard or used of D3? It's based on jQuery. It's a pretty straightforward, you know, rather simple, not overly complicated. You can do like crazy and wild things with it too. I mean, you can do like really weird things with it. I mean, unfortunately, we didn't get to do those. We did it, but in the privacy of my bedroom, I do a lot of weird things. So anyway, and that was, again, because that's a JavaScript library, for them to implement it, you just say, you know, your include statement or whatever you do in a HTML page to include it, and you're done. It's very similar in practice to something like Tableau, and we did look, actually the original pilot one I showed of the looked more like a dashboard in my beginning slide. We developed that in Tableau just because that was much more rapid prototyping at the time for us. There's differences, but there's similarities between them as well. Any other questions about that? So let me go back to the demo site, because there's a couple things I want to show here. what we did, and I'm going to go back to my demo platform, because once we did this, I mean, this is, now none of this has been implemented yet, it may be implemented in time, but once we had our hands on this open data, and we saw what D3, in this case, could do with it, it opened up all these other possibilities. This is a pretty robust data set, this EQUAR data set. There's, I think, 150,000 rows and 25 columns. There's a lot of data in there. They take all that data and they produce 75 relatively straightforward, simple tables, but there's a richness of data there. So we started looking at it and said, well, you know, you could do other things. You could look at it by county, for instance, because a lot of times, you know, I don't care what CBPHP is doing in Buffalo. You know, I care about what they're doing in Albany. So if you want, so now we could, and that information was in the data set, so we said, well, why don't we just add that as a category? So now this is the same thing you saw before, except now we have a county column. So you can look at it by county. So it didn't require much change in the code. It required nothing to do in the database. The other thing you could do, because it has years going back, I think, to 2008, you could look at it. This is looking at one measure, I just picked bronchitis, across a series of years. And you could go back more years than these, but this, we just picked 4. So you can see what was happening in 2013, 14, 15, 16. So you can, I mean, if you needed to, you know, you could pick out trends or whatever you want to see there. Or the same thing, except now you're looking at the plans with all the years. So you can see, for instance, CBPHP, and this is 2013. Is it 13? 2013, 14, 15, 16. So you can see how PHP is doing over time, how this one's doing. So there's different ways of mixing and matching the data. Again, basically the same code base, absolutely the same data set, just all different options. So that was the one big thing we had. I'm not going to get into the code, but trust me, it's easy. What I do want to show is this. So when we went into the last phase, where we took what we've done with EQUAR and started applying it to other programming. So now these are not only different data sets, these are completely different program areas within DOH. So there's, you know, adult care facilities, vital statistics, managed long-term care, different. And this menu that I'm showing to you right now was actually created with the same visualization tool we used to create the charts and graphs. So I mean, these tools have a lot of applications beyond what they might immediately. So I mean, this is just a nicer way to make a menu system, we thought. So where you can go through and start to see all the different, you know, charts. So we create, you know, we create loads of charts and graphs and maps and other things. But let me look at one chart here quickly. So this isn't implemented yet, but it may be implemented soon or someday. Again, this was something that was commonly done in their annual report, where they had a chart that showed population distribution, and then down below there's a table to meet those accessibility needs. And it also, you know, just it's a nice way of getting the information. You can see that you can see things in the chart, but then you can go down there and verify them in the table. And again, because the data has a richness of data to it, you could say, well, just show me what's in New Rochelle. So with a click of a button, you can see a whole new way of looking at it. I'll go back to where we were. If you don't like the bar chart, you can click there and see it in the line chart. And maybe in some ways that's a better way of displaying the same result. That's in terms of the flexibility we were trying to implement. And again, you can hover over things and get more information. So and again, it's a relatively simple code base that allows you to make these types of modifications. Then, what we started to do, because some of these areas had mapping information in them, was, well, can we use this open data to create maps? Now here we went to another JavaScript library, still within that same family of tools, same open source JavaScript library. This one just happened to be called Raphael. And again, getting back to that slide about how do you pick the tool to match the needs of the project and the team. We needed, there's millions of ways to create a map, and maps are a lot of fun to work with. But we needed a map that would, first of all, have the county outlines in it, would have the labels for the counties in them, would be responsive, so that, if you went down to a mobile device or a tablet, that the map would, respond appropriately. So all those kind of factors came into play. And we wanted it to fit within our basic JavaScript library framework. So that's how we ended up choosing this particular tool to do it. But what you'll see with this map, you can hover over things, and get a little more information. You can, highlight or de-highlight things. So if you just wanted to see the counties that have 32.4% or 35%, whatever you can do. So there's a lot of flexibility within the map. So again, even though it's a different library, pretty much the same approach, pretty much the same type of code to do the slightly different thing. You can zoom in if you wanted to. You can zoom out. You can do all sorts of things with it. You could also, this is kind of neat, change the colors. If you don't like those colors, you can go green. You can go green. You can go Albany gray. Makes you feel more at home. So, and you can change the year, so there's all those kinds of options. But again, those things, I'm making fun of them, those things are kind of important from a user standpoint. We tried to match the color palette of the DOH with our primary color there. I want to go back a couple more things. This is a directory. This might be DOH had this before, where they had a directory of all their adult care facilities, which is really kind of helpful. You could go through, you could see where they were, all the information, you could print it out. If you're going to a site, you could print it out and take it. But it had a few things it didn't have. For instance, it didn't have a map to show. So what they did a couple of years ago, they dropped the listing and they went to this mapping thing, which is from their open data set. It's from their Socrata data set. It's an embedded map from there, and you can go in, you can click it, and you could go and get information, and you can view stuff on the Google map. So they had a lot of advantages too. But when they got this, they dropped the other. So people started asking, hey, why can't I print out the directions? So they wanted to go back and say, geez, we like the map, but we like the other one too. What can we do there? And the other bad thing, I shouldn't say bad, the other thing that wasn't as helpful with this map is that it's not really, because it's an embedded, it's not really responsive. So as you go down, it's not great on a phone, in other words. So what we looked to do was to say, well, could we, using our tools? So there, this is the map we created with that tool. It is responsive. You can go in, you still hover and get information. You can click on it and still go. So now you have all the map features with all the printing features. Again, all using the open data source. Last thing. Corinne was asking me why I was walking around with the sports page. That's not the sports page. In the middle of this project, I stopped at our Cumberland Farms on the way to work to get the local paper of record, the Register Star, which I don't know, you may or may not have a subscription to. But I noticed this map. I said, wow, that looks familiar, And it's a map of unemployment rates by county, New York State, March 2017. So I got to work and I said, well, I'm going to go to the labor site and see what they got. And I looked up, I saw they had all those maps. They had like lists and lists of all these maps of as PDFs. I said, well, they must have an open data set of that, right? So I looked and there was, and lo and behold, because we already had the code for creating the map, I just plugged into their open data set using the URL, their endpoint for their open data set, and boom, there's their map. Same map, March 2017. except we can change the colors. We can pick other months. We can pick other years. So again, because it's leveraging that open data set, everything within that open data set is now available as a map. We did the same, I'm not going to go and show you, we did the same thing with another map on ag and markets where I did the pinpoint stuff. So again, that was a portability factor of the project that we didn't initially anticipate, but it was not only within DOH, within other departments within DOH, but actually outside of DOH. The same, and it took, I'm not going to make it sound too transparent, but you know, it took a little bit of tweaking of the code, maybe less than an hour's worth of code. I know I had it done before I drank my Cumberland Farms coffee that morning to get the DOH Labor Department map. So the last thing I'll show you is we have that map out on GitHub. This is CTG on GitHub. If you go where we have 4 different examples of it, just if you just want the shell of the map and do whatever you want to do with it, it's SVG based, it's responsive, it's JavaScript SVG. We have the shell with the outlines and the county labels. We have one that shows some that chloroplat type idea with the different colors filled in, and then one with the pinpoint locations. So we have 4 different ways to use it. It's available on GitHub, which is GitHub CTGU Albany, New York State County Maps. I probably.
Do you deal with that sensitive data in the same way that you would deal with this data, other than leveraging, you know, open data? Like, do you use Tableau, or do you defer back to or revert back to whatever internal or ITS solution you have for that?
So internally, we leverage Tableau as well. So right, we'll have you know, like one Tableau data source, and then we have several different workbooks that, like, you know, use that data source. And right, there are some workbooks that are meant for publishing, you know, up on our website, and then there's some used internally. And they're used for like project management stuff. They're also used to help clean up the data, to spot like the anomalies and stuff like that.
Yeah, and we didn't hear from the, I mean, we within CTG don't hear as much from the users outside of DOH, but the users inside of DOH, we would hear a lot from. And, you know, most of those were the drivers of the project anyway. So things like the tables I was showing, I didn't show you some of the most complicated tables. All those tables are also produced from the open data. It's not just the charts and graphs. We're using the same code to produce the tables. That saved them loads and loads of work. I mean, to take a raw data set and, you know, create all these, you know, some of the tables, there's one table in particular, it's only got five columns of data. It's not, and actually 4 meaningful columns. So it's a pretty simple data set. But you look at the table, it's got groupings, subgroupings across the top, more groupings along the side. There's numbers that have 1,000 commas in them, some that have decimal points. There's calculations for percentages. You know, there's a lot of manipulation of the data they have to go on to produce that complexity of the table. To do that by hand is, you know, very laborious. With this approach, that disappears. It's done. So from that standpoint, we hear a lot from them, or they'll come back and say, you know, now that we have this, can we do this as well? So, and we getting back to the FOIL thing, we did hear during the course of the project, the people we were working with, that's one of the things they were looking, not specifically only for FOIL, but just, you know, people call them up all the time. DOH asking them for information, and they can point them to the open data set, but it's not. You can't. That's not what the open data set is. Open data set is there to be able to use to produce other things. They'd love to have more of these types of things that answer those questions, so they don't have
to. So based on the success that you've seen in your organization and with groups that you're working with, like, have you also kind of established a philosophy of doing application development with the end goal of open data? So as you create your applications, plan for that stuff to become an open data set?
So we do. So in all of our, we call them like new builds. So whenever we're rolling out like a new initiative or a new program and having to build, the system that's going to collect and store that data, yes, it's now ingrained in there. First, it's ingrained that we classify the data to identify which elements are public and which elements are confidential. And then of those public elements, we automatically want to build right into the build process that, okay, we're going to have a Tableau data source that we then will push up onto Open New York and then connect to create the dashboard. So yes, we are building into like our process. That'll be like status quo. All new, programs and initiatives are expected to, be up on Open New York.
And we've begun to think more in terms of APIs all the time now. I mean, this is totally unrelated to open data, but we happen to be redoing our website, our internal website right now. And as part of that process, we're just creating APIs for the stuff on our web. Now, we don't know at this point if we're ever even going to use them, but it just sounds like a good idea, to have things in that format that are accessible in an open hook somewhere. So maybe we might not know it now, but maybe a year from now, we'd be saying, geez, we should have created an API for that, So yeah, I think that frame of mind is coming more prevalent.
Also something to consider as you're writing RFPs for COD solutions, is to add some language in there to cover, how do we get, other than the canned reports and the canned user interfaces, how do we get our data out of these systems that we're buying for potentially publishing to open data or for any other use?
And I would say too that Socrata API, at first I wasn't so crazy about when I first, like most things, you don't like them when you first taste them. But it's very good. I mean, it was very good to work with, I come more from a database background, so I was frustrated I didn't have all the really cool stuff that a really good database. But it's a very nice open data platform to work with. So I think regardless of any platform, that ability to have something to hook into and then be able to query and pull stuff out is really much more powerful than I even imagined when I started working.
And one of the nice things about it too, and it goes back to, the original publishing of the data set, is that the platform will also generate the API documentation for any data set. So as long as things like column descriptions have been populated, right, which is something that we really kind of harp on as we're publishing data sets, is to make sure that every column has some sort of a meaningful description. The platform, Socrata platform, will generate API documentation listing all the columns with the descriptions. So it makes it much easier for developers, much more approachable for developers to understand. I have one for the group. I'm wondering, as we were going through this and you saw some of these things, kind of a quick show of hands, has it spurred some thoughts about your own data, your own agencies? Yes, hopefully. That's great. That was one of my goals, is that maybe you could take some of these ideas back, talk about them among your agencies, talk about them among your IT support, and see how we can take open data to that next level. Thank you.
And thank you. We're right at